This lesson is over the angles of elevation and depression. The objective is students will be able to use trigonometry to find the angles of elevation, angles of depression, and find missing side lengths. So first off, what is the definition of angle of elevation and depression? The angle of elevation is the angle formed by a line of sight in the horizontal plane for an object above the horizontal. So if you are looking up at a plane, when you're looking straight, and then you look up at the plane, that angle that you move your head, that you move your neck, that is the angle of elevation. The angle of depression, the angle formed by the line of sight in the horizontal plane for an object below the horizontal. So the same example I used, except for now, if you think of you're in the plane and you're looking down at somebody, well, if you're looking straight, a straight horizontal line, and then you look down, that's the angle of depression. So I will say the angle of elevation makes a lot of sense. A lot of people are pretty good at it. It's very intuitive. The angle of depression is a little bit more difficult, and I'll tell you why here in a second. It helps to look at a picture. So this is a picture of a cat that's looking up at a bird, the bird that's looking down at the cat. So the important thing is make sure you're looking at the horizontal like we just talked about in that definition. The angle of elevation is this angle right here, the angle that the cat is looking up at the bird. That's pretty easy. A lot of people are pretty good at that. But the angle of depression is the angle of the bird. If the bird looks straight across at a horizontal line, and then that angle that it's looking down to look at that cat, that's the angle of depression. Now, the reason that the angle of depression is a lot more difficult, and you'll see this once we do some of these problems, is the way we're going to do a lot of this stuff, as you guys can imagine, is we're going to make a right triangle. So I'm going to make this right triangle where we have the line of sight and the horizontal, but the right triangle is going to be drawing a straight line down perpendicular with that horizontal. So the angle of elevation is easy. We'll just use trigonometry to find that. But then the angle of depression is not in our triangle. So when we find this angle here is what we're going to end up finding. And then we're going to have to do one more step to find the actual angle of elevation. But that's what a lot of people miss. That's why I wanted to say this right away. A lot of people miss the angle of depression because they find this angle. That's not the one we want. We want this angle up here, the angle that is going downward. So we'll get some practice problems with that. But that's literally all we're doing today. So we're going to go jump into some examples. You'll kind of see some different types of problems they'll ask. So number one, an 8-foot metal guy wire is attached to a broken stop sign to secure its position until the repairs can be made. Attached to the stake in the ground, the guy wire makes an angle of elevation of 51 degrees with the ground. How far from the foot of the stop sign is the stake? Round to 1 decimal place. Now, they draw you a picture over here for this one, so that's great. If they don't draw you a picture, you need to make your own picture. So first off, this is nice. They give you angle of elevation, so that's really handy. The angle of elevation is 51. They want to know how far from the foot of the stop sign is the stake, so they want this side right here. Well, again, with the picture, it's actually the same as what we've been doing, where you're just going to use trigonometry. So this is the angle we're talking about. We have a hypotenuse, and we have the adjacent. So if you remember your SOHCAHTOA, that is SOHCAHTOA, C-A-H, so you're using the cosine. So the cosine of 51 is equal to the adjacent over the hypotenuse, so that's x over 8. And then solve this just like we did last lesson. Put in your calculator, 8 times the cosine of 51. Make sure your calculator is in degrees. You should get x is equal to 5.034. And it says round to 1 decimal place, so that's going to end up being 5.0. Again, angle of depression isn't too bad. Now that one's kind of nice because they give you a picture, but if they don't give you a picture, you need to make one. So that's what we're going to do with this one. From a point on the ground, 47 feet from the foot of a tree, the angle of elevation to the top of the tree is 35 degrees. So this is kind of confusing. So a point that's on the ground. So let's first, over here, this is the ground. So we have a point on the ground. That point that's on the ground is 47 feet from the foot of a tree. So we'll have a tree over here. If you want to draw it in detail, you can, but you don't have to. That distance is 47 feet. Then it says the angle of elevation to the top of the tree This angle of elevation here is 35 degrees. Find the height of the tree. So we want to find how tall this tree is. So that's our right triangle here. So now we can use our trigonometry with this. We're trying to find how tall it is. So that's this length over here. So that's our opposite and our adjacent. So that's going to be SOHCAHTOA. So the tangent of 35 is equal to the opposite over the adjacent. Multiply both of these by 47. Similar thing we just did. And type in your calculator. 47 times the tangent of 35 is 32.90975. And it says around to 2 decimal places. So that's this one. That's 32.91. Now, go ahead and do this one on your own. Again, I would pause the video, do this on your own, then hit play so you can see if you got the right answer. But again, if you don't do any of these on your own, it's going to be really hard the first time you do one by yourself. So make sure the first time you do one by yourself is right now, not later on a test or a quiz. So Todd is taking a picture of a plane. Todd is standing with an angle of elevation of 23 degrees. The altitude of the plane is 1,200 meters. What is the distance Todd is to the plane? Around 2 decimal places. So we have Todd over here. He sees an airplane over here. I can't really draw an airplane. Something like that. That's not bad. And that is 23 degrees of elevation. The altitude of the plane, if we're talking about the altitude, that is the vertical height. So it says, what distance is Todd to the plane? So make sure you realize, and this is where this is a little bit difficult, when it says distance, if it says what's the ground distance or how far is it away on the ground, that's different. If it just says distance, this is the distance it's talking about. It wants this hypotenuse. So what is the distance he is away from the plane? That's the hypotenuse. If you're ever not sure what distance this is, if it's the hypotenuse or if it's this ground distance, ask me, because I don't want you to miss it just because of that. So we have our opposite and our hypotenuse, so we're going to use sine. So we have the sine of 23 is equal to the opposite over the hypotenuse is 1200 over the hypotenuse is our x. Now remember, this is the one where we have the x in the denominator, so we have to take these two and switch those. So we have x is equal to 1200 over sine 23. X is 3,071, round to 2 decimal places, so 0.16559. 2 decimal places would be 0.17. That 5 changes that 6 to a 7. So all those were angle of elevation problems. So now let's look at some angles of depression problems. On a windy day, a 90-foot rope tightly secures a hot air balloon to a stake in the ground. From the balloon, the angle of depression of the stake is 62 degrees. Find the height of the balloon to the nearest foot. So we want to know the height. The 90-foot rope is how we labeled this one, because this is that rope tied to the stake. And again, the depression, the angle of depression is this angle right here is 62. So here's why this is more difficult. And this is why we picked one with that had a picture first. You are not using trigonometry with this 62. If I want to know what this height is, I guess technically you could make one over here and you could use this angle of 62. But instead, I'm going to use the other angle just the way it's set up. So I guess technically you could do that, but to make it easier for yourself, if this is 62, this whole thing is 90 degrees. That's the whole idea. So if that first angle is 62, then what's this angle going to be? Well, if the whole thing is 90 degrees, this one is 62. If we take that out of there, what do we have left? 28. So this is 28 degrees. Now we can use that to find the height. Now again, there's a couple other ways to do it, but I think that's the easiest way. Now we just forget about that 62 for now and just look at that 28. So we have the hypotenuse and the adjacent. So that's going to be cosine again. So the cosine, whoops, dyslexia. Cosine of 28 is equal to the adjacent over the hypotenuse. Multiply both sides by 90. 90 times cosine of 28 is 79.4652, and it's to the nearest foot, so the nearest foot would just be this 79, so that's 79 foot. That 4 doesn't make that 79 into 80. So this one, you're going to have to draw a picture. Now, again, if you want to draw real detailed pictures, you can, but you really don't have to as long as you end up with a triangle. So from a hayloft door, so if you guys don't know what a hayloft door is, that's the second story of a barn. The hayloft door, Ted sees a dog on the ground. So Ted is up here, there's a dog on the ground over here, so I'm going to guess that we're going to end up with a triangle somewhat like this. Ted's eye level is 16 foot above the ground. Oh, sorry, the angle of depression is 40 degrees. Now again, that's not this angle, that's not 40 degrees. The angle of depression is this, is 40 degrees. Which means this, again, that's got to be 90 degrees here. So if this is 40, this one has to be 50. So now we have 50, we have 16. How far must the dog walk to reach the open barn door directly below Ted? So this is the length they're hinting at. This is the opposite and the adjacent. So we're using tangent. So Katoa of 50 is equal to the opposite over the adjacent. And from here, multiply both sides by 16. 16 times the tangent of 50 is 19.0680. Round to 2 decimal places, so that 8 changes that 6 to a 7. Now again, we have a you-do section of this. So if I were you, I would pause the video, I would do it on my own, and then I would hit play on the video to make sure you got the right answer. I was standing at the top of a sled hill that is 25 feet tall. So we already say this is the sled hill that's 25 feet tall. I was looking down at my daughter at the bottom of the hill, so she slid down, so she's somewhere over here. The angle of depression I was looking down at was 50 degrees. So the angle of depression, this one, 50 degrees. How far away from the base of the hill was my daughter? So how far away from the base of the hill is what we're going to say. So again, if this is 50, this has got to be 90 degrees, so this has to be 40. 40 and 50 add up, that angle addition postulate, if you remember. So again, we're going to use the tangent. We have the opposite and the adjacent. So the tangent of 40 degrees is equal to the opposite over the adjacent. Multiply both sides by 25. And use your calculator. 25 times the tangent of 40 is 20.9774. This one doesn't tell you where to round to, so I'd go to 2 decimal places. That 7 rounds that to 9/8. So that's the angle of elevation and depression, but now we're going to do some that are a little bit different. So far, all of them that they've given us, they give us the angle, and we have to find one of the lengths. So this one, they gave us the angle of 50 degrees. We had to use that. This one, they gave us the angle of 40 degrees, the angle of 62 degrees. They gave us all that. Now we're going to be finding the angle. So this one isn't a lot different. You're just using the inverse of those trig functions. So a shopper is standing on level ground 800 feet from the base of a 250-foot tall department store. So this department store is 250 tall. The person is standing 800 feet from the base of that department store. The shopper looks up and sees a flag on the store's roof. To the nearest degree, what is the angle of elevation? So this shopper is looking up, and they ask for the angle of elevation. That's this one. What is that angle? So we have the opposite and the adjacent, so we're going to use tangent again. Tangent of the angle, which we don't know, is equal to the opposite, 250, over the adjacent, 800. And remember, to solve this one, we need to get rid of tangent. So we just have the angle by itself. So to do that, it's the inverse of tangent. So your theta is the inverse of tangent, 250 over 800. Type that in your calculator. And again, I would type it out exactly how you see it. The inverse tangent, 250 divided by 800 is 17.354. And I don't know if it says this. Yeah, right here. To the nearest degree. So the nearest degree means we're not doing the 1, 2, or 3 decimal places. It's just that 3 doesn't do anything with that 17. So it's 17 degrees. The nearest whole degree. So that was the angle of elevation, not too bad. This one's going to be a little bit more difficult because it's the angle of depression. So a koala is sitting at the top of a tree 30 foot above the ground. That koala is looking down at a kangaroo that's 50 foot away. And again, if you're not sure if it's 50 foot from the base or 50 foot from this side, your hypotenuse, just ask me because I'll let you know. This one's a little bit vague. I'll try to be more specific on a test. But 50 foot away, I meant away from the tree. What is the angle of depression to the koala's line of sight? So the angle of depression. Now again, the problem with this is a lot of you guys will find this angle and you'll put that as your answer. But the angle of depression is this angle. So we're going to first find this one. But we're going to use that then to find that red angle. So we have the opposite and adjacent. So we're using tangent again. That happens kind of a lot in this. Tangent of theta is equal to the opposite over the adjacent. So again, we're doing the inverse tangent. So theta is the inverse tangent of 50 over 30. That ends up being 59 degrees, and it says, again, round to the nearest degree. A lot of times when we're talking about degrees, they'll have you round to the nearest one, so that is just 59. And again, that's where a lot of people circle it, and they say that's their answer. So that's this angle measurement. The angle of depression is this one. So if that's 59, remember the whole angle is 90 degrees. So 90 minus 59 is 31. So this has got to be 31 degrees. That's the angle of depression. So now I have two of them that you guys can do. Again, one's elevation, one's depression. Pause this, do it on your own, then watch this. A flagpole is 18 foot tall. Cast a shadow that's 12 feet long. At a specific time of day, find the angle of elevation that the sun is. So the angle of elevation has got to be this one. Now again, don't just always assume that it's tangent. Always double check. We have our opposite and our adjacent. But again, we do end up using tangent a lot. And again, be careful because when we're talking about the angle of depression, our opposite and our adjacent were different. So make sure you're being careful. This is the angle we're looking for. So we have opposite and adjacent. 18 over 12, inverse, to get rid of your tangent. And type that out. The inverse tangent of 18 divided by 12 is 56.309, and we round to the nearest degree, so that's 56. And again, we're talking about the angle of elevation, so we're good. We don't have to do anything else. The next one, a pirate standing in a crow's nest 60 foot above the water. He sees a dolphin on the surface of the water 150 feet away. Again, I'm going to assume that's away from the boat. If you're not sure, please ask. What is the angle of depression that the pirate is looking? So again, the angle of depression is this angle. We just have to use this angle to get to that point. So again, now we have the opposite and the adjacent, so it's definitely tangent. The opposite is 150, the adjacent is 60. And inverse tangent, hopefully you guys are getting pretty decent at this by now. The inverse tangent of 150 over 60. Type that out. Inverse tangent 150, whoops, is 68.198. Now again, we're doing it around this nearest degree. Just making sure. So again, that's not our answer. That means this is 68 degrees, but then what's that blue angle I have marked here? Well, 90 minus 68 is 22. Always make sure you double check that angle of depression. Now the last one I have on here is just more of a challenge problem. Simon bought a new shop and he wants to order a new sign for the roof of the building. From point P, he finds the angle of elevation to the top of the roof from the ground level is 31 degrees, and the angle of elevation to the top of the sign is 42 degrees. The point P is 24 foot away from the building. How tall is the sign? So we want to find this length of the sign, how tall it is. And the way they're doing that is he's saying that it's 32 degrees to the top of this building, but it's 42 degrees, sorry, 31 degrees, if I said that wrong, 42 degrees to the top of the sign. So really, we're going to do this twice, and we're going to find this length here in green. You can really see it. And then this length here in red, we'll call that Y just because we already used X. And then we're going to see the difference. So if we're looking at the green one first, that's to the top of the roof. That's 31 and 24. 31 is the angle. So we're looking for the opposite. We have adjacent, so again it's tangent is equal to the opposite over the adjacent. Multiply both sides by 24. You end up getting 24 times the tangent of 31 is 14.42. Says 2 decimal places, so I'll leave it at that. So 14.42, that is to the top of this building. 14.42. Again, you can't really see it too well, but that's okay. Now we're going to do the same thing to the top of the sign. Now the angle is 42, but everything else is the same. 24, this is X, that's our opposite, this is our adjacent. So really, you can almost do the same thing, just put 42 in there. Tangent of 42 is equal to X over 24. Multiply by 24. 24 times the tangent of 42 is 21.609, which means that's 21.61. So that's the whole thing. So if the building was 14.42, and the whole thing with the building and the sign is this, then what's this little length right here? Well, we just subtract those. 21.61 minus 14.42. 21.61 minus 14.42. That sign is 7.19 feet tall. Yeah, because this is measured in feet right here. So that's really not that big of a, not hard of a problem. You have to think about it, and you have to do a little bit more work. You have to do everything twice. I don't think you'll have one that's that hard on the test unless it is a bonus question, but it's a good one to get you guys thinking and to get you to see a couple different things. If you have any questions, make sure you let me know. Have a good day and good luck.